In this video, I'm going to teach you how to interpret the drawings, HVAC drawings, especially on the air side. And of course, I'll take a look at the BMS schematic and how to interpret the data inside. So once you have understand all the different equipments, the acronyms inside the HVAC air distribution system, alright, it will be easier to interpret the mechanical drawings. Alright, but however, if you take a look at the plan view, it may be very complicated because it's full of lines, full of symbols, full of numbers. So, and especially if the ducts, they overlap each other, right, it's very hard to see. Alright, so so it may take a little bit of experience and practice in order to look at the diagram accurately. But nowadays, usually new buildings, okay, they like to use a 3D model, okay, such as using building information modeling to model the MEP, which stands for mechanical, electrical, and plumbing. Right, so once you have a 3D model, actually it's much more easier to visualize it. So let's take a look at an actual drawing, all right, and try to make sense out of it. So this is a mechanical drawing of a AHU room. Alright, so you have an AHU that is supplying air around through some air ducting. Alright, so some of the terms to look out for example, 1200 times 1100, all these numbers represent the dimension of the duct. Alright, so the duct is actually 1200 millimeter multiplied by 1001 millimeter, so it's almost a square duct, and SAD stands for supply air duct. So this supply air duct is coming out from the AHU and supply to maybe the different spaces. Alright, and when you see the symbol, alright, that is a rectangle with a slash from one corner to the end and create two triangles. This is what we call a return air duct symbol. Alright, so return air duct is a slash and supply air duct is a cross. Alright, it's a cross. So this is also a supply air duct, so it's a cross. Okay, so return air duct is RAD, return air duct, and fresh air duct is FAD. Alright, fresh air duct. And CHWS, CHWR with a diameter. So this one representing the chilled water supply and chilled water return pipes. Alright, the one that looks smaller are actually pipes, they are not ducts. Alright, the ducts are the one that looks much bigger. Alright, so you may also notice that you tend to see this like R750, R550, this represent the radius, right? The radius of the elbow. Okay, the bigger is the number, of course, the longer will be the sweep. Alright, the turn will be much more gentle. Alright, so these are some of the few things that I can talk about over here. Oh yeah, and why are there a lot of these test hole? Alright, so all these test holes are for measurements. Alright, it's for measurements of flow rate. In order, let's say you want to do some maintenance and servicing, you want to check the flow rate against the sensor reading. That's where you are going to use the test hole, where it's a small opening that you can open up and you can put your pitot tube to measure the airflow rate, alright, and the pressure. Alright, so maybe let's write down what we have discussed just now. SAD is supply air duct. Alright, supply air that just come out from the AHU will come out from the supply air duct. RAD is return air duct, which is the air after it has absorbed heat from the room, it will go back to the AHU through the return air duct. FAD is fresh air duct, and fresh air duct usually will be a bit smaller. Okay, it will be smaller than the supply and return duct. CHWS is chilled water supply. Chilled water supply where the chiller will produce cold water and it will be supplied to the AHU through the chilled water supply pipe. And CHWR is chilled water return. Alright, so all these are very, very common acronyms that you will see in drawings and whenever we describe HVAC pipes and equipments. All these are very common terms. R with a number is the radius, alright, of the elbow. And sometimes in the same drawing you will see the equipment schedule. That means they will show you the equipment. That means the two AHU that you see inside the drawing, what are some of the information. All right, so there's the airflow information. For example, the supply airflow capacity is 50,000 cmh. That means this particular fan can supply up to 50,000 cmh of air. Okay, and it can overcome 885 Pascal of external static pressure, and the cooling capacity is 220 kilowatts. So all these may be you will, in the subsequent videos and topics, you will learn more about all these values. Okay, what are all these about, and how to size your equipment based on all these numbers. These are the three most critical numbers before we select a suitable AHU for the space. Then the rest are just some of the other information like the chilled water flow rate, the dimension, so that you know whether your room has enough space for it. And of course, in the same drawing, usually there will be all these legend, okay, which you can refer to. But most of the legends will look the same, and once you've seen it many times, you don't have to refer to the legend anymore. Okay, let's try to interpret the following drawings. Okay, what is the total capacity of AHU 1-1? Okay, AHU 1-1 is this particular AHU. So there are 4 numbers and there are 2 units over here. So the first one, kilowatts, of course, refer to the capacity. So total capacity is 48.6. Alright, the bigger number is the total capacity, and the slightly smaller number represent the sensible capacity. Okay, what is sensible, what is total, and there's another term that you will learn later called latent capacity. So all these you will learn in the subsequent topics. Alright, total airflow is of course the bigger number again. So this is 9,500 cmh. And the outdoor airflow is only 680, which is normal. Alright, so outdoor air usually is not as high. And finally, AHU 1-1 pipe size. So you can see that the pipe size is 50 mm. Alright, 50 mm. So this is the chilled water supply pipe size. The return pipe size will be the same size. Alright, another drawings over here. Okay, so number of air diffusers. Whenever you see multiple squares like this, alright, big square to a small square with arrows pointing outwards, it means this is an air diffuser. So there are actually total of 6 diffuser in this room. So 6 diffuser. How many VAV dampers or volume control dampers? There's actually 3. Okay, 1, 2, 3. Alright, so one damper is controlling 2 diffuser. Sorry, one damper is supplying air to 2 diffuser. Alright, so there are 3 VAV dampers. Supply air duct size. Alright, so you can see the supply air duct size. This is the main air duct size is actually over here. Alright, 300 times 200. Okay, 300 times 200 is the supply air duct size. Of course, over here, when it comes to a smaller duct is 200 times 150, but maybe the main one, okay, is 300 times 200. Okay, the airflow rate from each diffuser is also indicated over here, 1000 cmh. Alright, so 1000 cmh is for one VAV. So most probably one diffuser is 500. Alright, 500, because 1000 is split into 2. Alright, so it's 500 each. And finally, number of zones with temperature control. You can see the damper, there's a curvy line, and it's to this particular symbol. Actually, there's a T. Okay, if you look closely, there's a T inside. So it represents the temperature sensor or the thermostat. So actually, there are three zones. So one zone with one temperature sensor and one volume control damper. So there will be 3 particular zones. Alright, so that's how you interpret this kind of diagram. And finally, this is the BMS schematic that you will definitely see in all building management system on the air side. Alright, so this is for one particular AHU. Let's say your building have 20 AHU, you will have 20 pages like this. Because each AHU will have different readings. Alright, we'll have all different status, different readings. Alright, all the numbers you see over here in white color boxes, okay, all the white color boxes numbers are from your sensors. All right, for example, supply air temperature sensor will give you supply air temperature reading. Supply air static pressure, all right, will give you the pressure reading. The return air humidity, return air temperature, return air CO2 level, all right, off coil temperature. So all these are from your various sensors. Okay, as for those in yellow, okay, those in yellow are actually the set point that the users can set. All right, so but of course this is for this particular BMS vendor. Okay, different vendors will have slightly different looking, different color scheme, different theme of graphics. Okay, but all in all is usually like that. Okay, there will be a supply air over here, return air over here with a fan, cooling coil, and air filter. Okay, this is quite a standard kind of things that you will see in a BMS airside schematic. All right, so below the fan, usually it will show the fan speed. 50 hertz is the maximum. All right, so now it's running at around 70%, so around 35 hertz. All right, so you have the feedback, you have the command. All right, so command means I want it to run at 34.5, but now it is actually running at 34.9, so it's almost near to the command speed. All right, and of course the power consumption is shown over here. And below the cooling coil, you have some other information such as the flow rate, chilled water flow rate. All right, chilled water flow rate, the chilled water supply, and chilled water return temperature. All right, the chilled water supply temperature looks a bit weird. Okay, this is not a very typical chilled water supply temperature. So if you are experienced enough, sometimes one look at this, you will spot all the funny values that may be caused by your sensors. Your sensor may not be as accurate anymore or need some kind of servicing. All right, and PCC is pre-cool coil. All right, so this is a double coil system. That means before the outdoor air comes into the AHU, is actually being treated first. Okay, it's being air conditioned first by reducing a bit of the humidity and reduce a bit of the temperature before coming into the AHU. All right. And of course, there's all these words over here like on, normal, auto. All these are the status. All right, status of the equipment. So here it means the airflow switch. Okay, airflow switch is on. Okay, it means, right, there's air flowing through. Okay, it simply means there's air flowing through. So it's a check whether your fan is actually on. All right. Then of course your filter is clean. All right, it's okay. Then there's no trip, so it's normal. All right, then so on and so forth. All right, there's no smoke alarm. All right, so the smoke detector states that it's normal. So BMS is just like having a lot of your eyes, your it's like a body, your eyes, your ears, okay, all your sensors are around, okay, and it's consolidated into a one graphic for the users to look. All right, so instead of going on site and measure all the different readings, so by sitting in a central location, you will be able to know what is going on in your building, okay, by having all this temperature, all this data coming to you. All right, and of course the good thing about BMS is all this data also trended. That means it's being logged. Okay, so all these data are safe. So let's say I want to find out, oh, last week Tuesday there's something wrong with the temperature. Okay, I want to take a look. Okay, you will be able to do so via the BMS because the server will actually save all this data. All right, so hope you have a better idea on how to interpret either a mechanical drawing, a CAD drawing, or a BMS schematic.